Okay, for question 6, we are given a nested array of points, and from that nested in array, we will need to return the k closest points from the origin. Okay, so before we go into the actual algorithm, we know that, yeah, we will somehow need a distance method to keep things simpler, to divide things into like smaller blocks. And the data structures that we are dealing with is we have an integer k, and our point is represented as an int array of length 2, and our point is a nested int array. So going back to the distance method, we know that it will take in a parameter of like int array, which is our point. And to get the Euclidean distance between a point and the origin, we can use the formula, which is the sum of the square distances between the the sum of the square differences between the x and y coordinates of a point and the origin, which can be expressed as such. Note that in Java, we don't have a readily squaring method available to us, so it will be simplified further down to like the first index times the first index and the second index times the second index. Note that we are not applying the square root into our formula here because it doesn't really change things. It just helps us to simplify our operations. Okay, so yeah, going into the actual algorithm, we can just like name our class arbitrarily. I'm calling it solution. No, the solution is calling it solution. And yeah, so for the two methods here, like the first one, we can name our main method that will return the k closest points as k closest. We know that it will have a return type of nested in array, and it will take in a nested in array of points and also an integer k, right? And for the distance method, it will have a return type of int, and it will take in an integer array of points. And yeah, the code is just as we have discussed earlier. Okay, so let's now go into the k closest algorithm. Okay, to get the distances, the idea here is that we will first iterate through points using a for loop, and we will calculate the distance of each point, like between the point and the origin, and we will have to save it into a distance array. So to get the distance array data structure ready, you can like declare and instantiate it now. We know that it will be an integer array, and like its length would just be the number of points we have. So we can save the number of points we have into this integer variable name type n, which would just be like points dot length. Yeah, and then we can use it here. Okay, and now we can go through with the for loop. That is, for each I index of distance, it would just be the distance between the ith point and the origin. Okay, so that's done. To get the k closest points, first of all, we can sort our distance array first, using arrays dot sort, and yeah, we can also get our returning data structure ready, which is a nested in array. So it can be something like this. I'm calling it RET, short for return. And we know that we will have k points, and each point will be an array of length 2. So it will return RET around here. Okay. To get our K closest points, the actual algorithm will be that we will again iterate through our points array using a for loop, and we will calculate the distance between each point and the origin, and we will use a item in the distance array as a reference point. Like to elaborate further, if my n equals to 3 and k equals to 2, that means that my sorted distance array will have like 3 items here, and my k closest points, like we know that the distance between each of the k closest points will be less or equal to the second distance over here. And so it will be something like distance point I lesser than or equals to our distance with index k minus 1. Okay, so I hope that's clear, so we can now continue further with our algorithm. Okay, yeah, as mentioned, let's get our reference point ready. Yeah, I'll just name it as REF, which is just the k item in our distance array. The index will be k minus 1. So the for loop will look something like this. Yeah, the if condition will be if distance, if distance of the I point is lesser than or equal to our reference distance, then we will add it to our returning data structure. Okay, yeah, we will add a pointer to our returning data structure. So now the problem is that how do I index the returning data structure, right? To help us with that, we can introduce a new integer named t here, and we can also use the idea of like post increment. That means post increments means that the variable will only be incremented after the line is run. So in this case, like with t instantiated to be 0, like RET with the index of t will be like the 0 index of RET first, and after this line is run, meaning that we have already added the points into the returning structure, then t will be incremented to 1, and so on and so forth. Yeah, so yes, that is our solution here. Thank you.